alright. Today we'll discuss about the development of a human being from first week going to the second week and reaching the third week of development. If this is the first week of development, second week and the third week of development, what are the sequence of events happening through these weeks? First week, we will discuss ovulation and we will end at the implantation. So first week begins with the ovulation, ends with the implantation. More precisely, implantation begins in the first week, but implantation ends in the second week of development. In the second week, what happens? First important thing is implantation is completed. There's completion of implantation. Second important event is the formation of double-layered embryo, which is known as bilaminar germ disc. See, this embryo is first double-layered in the second week, then it becomes triple-layered. That means trilaminar embryo is formed in the third week. So this is the second week of development and this is the third week of development. So in the third week, we are going to discuss the trilaminar germ disc. Is that okay? I would like to mention here that it is the week of twos. Second week is the week of twos. Every event is happening in the form of a double number. Now we'll discuss the first week of development first. Now see here, we'll go diagrammatically more. This is the ovary. At the time of ovulation, under the influence of increased level of especially the LH hormone and also the FSH is also high. So this is the surge of LH and FSH resulting into the kicking out, exactly the kicking out of the oocyte from the ovary. This oocyte is still not the mature ovum. It is still not the definitive ovum. One meiotic division, the final meiotic division, is still pending when it is ovulated on the surface of ovary, and this extruded, kicked out structure is the secondary oocyte, not the definitive ovum. Is that okay? Right. So when it is kicked out, obviously nature has always made the feminine feature as the protective. Protection around the secondary oocyte is a double-layered security. Mind it, this is a double-layered security. This is the secondary oocyte. It is surrounded by a layer of zona pellucida. This is the inner security, bodyguards. And outside of this zona, there are some cells which have been kicked out during ovulation. These are the follicular cells. They arrange around the secondary oocyte and form the corona radiata. So this layer is corona radiata. So if the sperm has to fertilize this oocyte, it will definitely have to cross these barriers. See, their females always are protected by the barriers. This is the natural phenomenon which we can see in the reproductive time also. So this sperm will first pass through the corona radiata. It will break the first layer of security, then it will break the second layer of security, then it will touch the oocyte membrane, and this will be the third step of reaching up to the oocyte. So if that young guy has to meet this oocyte, it will have to cross the barriers. So now when this ovary is about to ovulate, the fimbria of the uterine tube starts to sweep on the surface of the ovary, right? So on the surface of the ovary, there are movements of fimbria which have increased. It was not before, but right now, when it is about to ovulate, they start, these finger-like projections which are the fimbriae, they start to sweep over the surface, telling the ovary that please be easy and release the ovum, we are ready to pick it up. As soon as the oocyte is released, the fimbria pick this oocyte and give it to the ampulla of the uterine tube. Remember this thing, ampulla is the region for fertilization. So fertilization happens in the ampullary part of the uterine tube, right? So now the cilia inside the lining of the uterine duct plus the fimbria have picked up and pushed the oocyte into the ampulla. Now it is waiting here for the sperm to come and fertilize it, right? So now the oocyte is here and it is around day 14 of the reproductive cycle, right? Now as you know, the females are something high maintenance. Nature has made them like that. So it will wait for the sperm not more than 24 hours, right? In some females it is 48 hours, but only one day, most of the time only one day it will wait. If the sperm does not reach here to the ampulla to fertilize this will die and the story will end there, right? So oocyte is transported to the ampulla. Now this is the ejaculate which is deposited not in the cervix. Remember this, ejaculate, the semen, is not deposited in the cervix, it is deposited in the vagina part of the female reproductive tract. So here we have these happy sperms very excited to meet this oocyte. Okay, they will be transported and they will travel a very long distance to reach the ampulla. See, again, this is a natural phenomenon. Females do not travel long. The male portion is too much wild and too much happy, so they will travel a long distance. You can call them stupid, you can call them passionate, it's up to you. So this is the region where fertilization happens, and fertilization is day 1 of development. Always remember, in terms of development, fertilization is counted day 1. Is that okay? Fine. When it has to fertilize, it will first cross this, it will first cross the corona radiata, right? So it has to remove its cap. This is the sperm and it is quite happy to meet the oocyte, but it is having a cap, right? This is the acrosome cap, one is the plasma membrane, and on the head it has some glycoprotein molecules. So when this sperm has entered into the palace of this princess, now before meeting the princess it has to follow some protocol, right? So it will have to wash out these glycoproteins from the head. This is called capacitation, right? So he is very happy, very innocently. He is thinking maybe hairstyling impresses the princess, right? So first of all, this fallopian tube mucosa, it will wash the head of the sperm. This is called the conditioning, head conditioning of the sperm, right? So this head conditioning removes all the glycoprotein. Removal of the glycoprotein, this is called capacitation process. Capacitated sperm can cross first security layer. Now it can cross the corona radiata and go to touch the zona pellucida, right? When it touches the zona pellucida, second reaction comes into play, that is called acrosomal reaction. Right. So for fertilization, first it has to remove the cap. Now it is allowed to enter through the corona radiata. Now it touches the zona pellucida, the second immediate security. When it touches the zona, this zona induces the acrosome reaction. Now this poor sperm loses the head also. Some portion of the head is also lost. He did not know that this is not just a simple swimming race. This is a kind of military training. It has challenges, right? So now when it touches the zona pellucida, acrosome reaction happens and the plasma membrane on the head of the sperm, this is degenerated, this is melted away. Right? Now the sperm can touch the membrane of the oocyte, and now when it has reached up to here, almost successful, this is the only single sperm which is allowed to pass through the security. So it is the fastest and the fittest sperm. Out of 300 million deposited here, only 300 reaches here, and only one can penetrate through the layers of the oocyte. You understand? Always the mothers say, मेरा बच्चा लाखों में एक है. It is actually लाखों में एक है. 300 million, which may be up to 500 million. On an average, there are 200 to 300 million sperms deposited in the vagina. Only 300 to 500 they reach here in the ampulla. Only one gets the chance to meet the princess. Okay? Right. So see how much sacrifice a sperm has to do. It has to remove the capacitation. Right. It has to lose the plasma membrane of the head region. This is called acrosome reaction. Now it has to meet the oocyte membrane, and finally it leaves all its dresses out and jumps with the tail inside the oocyte, inside the cytoplasm of this oocyte. But when it just touched the membrane of the oocyte, this oocyte very affectionately held the hands tightly. Held the hands of who? The sperm. So here, integrin molecules of the oocyte membrane and disintegrin molecules of the sperm, they actually join their hands, so that he has reached so far, he should not fall back. So the oocyte shows this much of generosity. It holds the hand of the sperm tightly. So this is the plasma membrane, not of the head, which is holding hands. You understand? It is the plasma membrane of the sperm, which is the posterior sided portion of the plasma membrane of head of the sperm, which attaches to the oocyte. So this is how the fertilization actually happens. Now after fertilization, this undergoes first division starts with the first cleavage starts with the process of fertilization. So with the first cleavage, it is a 2-celled embryo right now, right? Then it is 4-celled embryo with the second cleavage. Then it converts into the 8-celled embryo. And now it is 16-celled structure. This 16-cell embryo is now known as morula. Why morula? Because it is resembling to the mulberry fruit. So it is 16-celled morula. Now at this stage, rather on the 8-cell stage, the process of compaction started in the embryo. What is this compaction? Compaction is getting the cells compact and forming a compact mass. Just as similar, there must be cricket fans out here. In the cricket game, the players, they make a strategy, right? They come closer to each other, they keep their hands on the shoulder, they hug each other, they are very tightly enclosed each other, right? So that, something like that happens in the embryo also. The cells which are on the inside the core of this embryo, they start to become compactly arranged, and this process is known as compaction. Due to this compact arrangement, now this morula has compact cells on the inside and loose cells on the outside. This is the outer cell mass, and this is the inner cell mass. You understand? Now this morula has jumped into the cavity of the, here is the 16-celled morula which jumps into the cavity of the uterus and stays there for day 4 and day 5. For 2 days it keeps on floating and swimming in the uteri fluid. You understand? So, day 4 ending and the beginning of somewhat day 5, we have morula converted into blastocyst. Now, what is this blastocyst? This is an embryo. Blastocyst is nothing but it is an embryo, but it is the cyst bearing embryo. Is that okay? That means when it was floating, this morula was floating in the uterine fluid for 2 days, then the fluid of the uterus started to seep inside the morula, which this fluid pushed the inner cell mass of the morula to one corner. These are the loosely arranged outer cell mass and the inner compact cells. Now they talked to each other. These inner cell mass of the morula gathered together, held their hands very tightly through tight junctions and communicated the big baby plan. This communication between the cells happens through gap junctions. Tight junctions bring them compact. Gap junctions helps them to communicate their strategy with each other. Fine? So, now this fluid which is collected, which seeps in from the uterine cavity, it enters into the morula, pushes the inner cell mass to one corner, and now this morula is no more morula, it is now known as blastocyst. It has a cavity known as blastocele cavity. This blastocele cavity is inside the blastocyst, and this cell is known as embryo, blast, and no more inner mass. And the outer cells are known as trophoblast. Right? So we have this blastocyst having a cavity, having the inner cell mass now known as embryoblast, having the outer cell mass now known as trophoblast.